At first glance, this just looks like a standard high school chemistry exam, right? A bunch of problems you have to solve. But what if I told you it's actually something more? Today, we're going to treat this exam like a secret guide, one that unlocks the fundamental tools every scientist uses to make sense of the world. Let's dive in. So this exam paper from Tyrus College is going to be our source material. And look, we're not trying to get an A+ here. Instead, we're going to treat each problem as a case study that reveals a really powerful method in any chemist's toolkit. Think of it as a series of scientific detective stories. So, here's the game plan. First, we'll introduce the idea of the chemist's toolkit. Then, we'll unpack 3 essential tools, one for chemical accounting, one for timing reactions, and one for crafting new molecules. And finally, we'll see how these problems on a page become real, powerful principles out in the world.
Okay, so let's jump right in with a super practical question that comes straight from this exam. Imagine you buy a descaler for your coffee machine. The label says it's made of a specific chemical. But how do you really know? How can you be sure you're actually getting what you paid for?
And that question brings us perfectly to our very first tool, titration. The best way to think about it is as a kind of chemical accounting. It's how we meticulously take inventory of the molecules in a solution to find out exactly how much of something is really in there.
So here's our mission. We've got a half-gram sample of this descaler powder. The challenge is to figure out what percentage of it is the actual active ingredient, sulfamic acid, and how much of it is, just filler.
So how do we solve this? We use titration. We take our descaler, which is our unknown, and dissolve it in water. Then we carefully, drop by drop, add a different solution that we know everything about, in this case, sodium hydroxide. By measuring exactly how much of the sodium hydroxide it takes to react with all the acid, we can do some simple math to work backwards and find the original amount. It's brilliant.
And this is the cool part. A really simple formula turns this whole physical process into a precise calculation. Step 1, you've got your core equation. Then in step 2, you just plug in the values you know, the concentration and volume of the sodium hydroxide we added, and the volume of our sample. This lets us solve for the one thing we don't know in step 3, the acid's concentration. And once you have that number, you're golden.
So you run the numbers and boom, there's our answer. The descaler powder is 77.6% pure sulfuric acid. That's the power of chemical accounting right there. It turns a question of, I wonder if, into a definitive statement of, here's exactly what is. No guesswork.
Okay, but knowing what's there is only part of the story, right? Sometimes the most important question is actually, how fast do things happen? And that brings us to our second tool, the science of kinetics, which is really just the study of speed in the chemical world. The exam gives us this raw data from an experiment. Basically, scientists took an alcohol, oxidized it, and then measured how much of the new product was being created over a 6-minute period. At first, it's just a table of numbers. But this data actually tells a story. Just look at the numbers for a second. What do you notice about how the speed is changing as time goes on? Just kind of track the jumps from 1 minute to the next. What's the pattern? See, this reveals something fundamental about how reactions work. It comes out of the gate flying, making 35 units in that very first minute. But then, it slows way down. Only 20 units in the second minute, then 13 in the third. So why is that? It's pretty simple, actually. The ingredients you started with, the reactants, are getting used up. The fuel for the reaction is literally running out.
All right, so we can measure what's there, and we can time how fast it changes. Our third tool is all about actively making new things. It's called synthesis. And in this case, we're going to use the act of creating a new molecule to solve a mystery about one of our starting ingredients.
So here's the setup from the exam. We have an unknown alcohol. We know the chemical formula, but there are a couple of different ways the atoms could be arranged. So we react it with an acid to make an ester. Esters are often the compounds that give things like fruit and flowers their distinct smell. The big question is, can the result of this reaction tell us exactly which alcohol we started with? So, after the reaction happens and settles into a stable balance, what chemists call equilibrium, we can measure what's in the flask. This lets us calculate a special value, a number called the equilibrium constant, or Kc. And for this specific reaction, that number comes out to be 1.34. And this is where that one little number solves the entire puzzle. You see, chemists have already done this work. They know the expected Kc value for different types of alcohols in this exact reaction. A primary alcohol, that would give you a Kc of 4.2, but a secondary alcohol gives you 1.34.
Our number is a perfect match. We just use the outcome of making something new to identify our mystery ingredient. How cool is that?
So let's bring it all together now. We started by looking at individual problems from a test, but what we've really been doing is building out the core principles of the chemist's toolkit.
Let's just do a quick recap. We've got titration, that's our chemical accountant for figuring out how much. We have kinetics, which is our stopwatch for understanding how fast. And we have synthesis, our construction kit for both creating new things and identifying what we have.
And this stuff is not just for passing a test, not by a long shot. Titration is used every day to ensure the quality of everything from the food we eat to the gasoline in our cars. Kinetics? That's the key to designing a pain reliever that works immediately versus one that releases its medicine slowly over 12 hours. And synthesis? Well, that's how we create everything from life-saving drugs to the clothes on our back.
So the next time you read a product label, or you wonder how a medicine works, or even just watch your food cook on the stove, remember this toolkit. Because science isn't just a collection of facts you have to memorize, it's a set of incredibly powerful tools for asking and answering your own questions about the world. So, what are you going to investigate?